My name's Ian Buck. I'm the Director of GPU Computing at NVIDIA for software. I received my PhD from Stanford in 2004. Basically, my research at Stanford was looking at general purpose programming models for GPUs and trying to understand how we could use these processors for things other than games and graphics. My PhD thesis was resulted in a software system called Brook, which was the first attempt at a general purpose programming model and language for GPU computing. NVIDIA was fortunate enough to help fund the work and was very interested. So I finished my thesis in 2004 and came to NVIDIA to take what was a research project to make it turn into a real commercial solution. That's when we started on CUDA, and for over 2 years we were doing internal software development, and finally shipped CUDA 1.0 back in 2006 with the GeForce 8800. As I always explain it, CUDA is an entire computing platform for doing C on the GPU. When we started CUDA, we had a lot of choices of what we could build. Some people were suggesting a full-on parallel new programming language. We could have done taken GL and added some extensions here and there to make it better supportive of computing. When we looked at it, the key thing when we're talking to customers is, they didn't really want to have to learn a new language. They didn't really want to have to learn a new API. Some of these guys were actually trying to hire game programmers to figure out how to use these GPUs because they knew they were fast, they just didn't know how to get to them. So providing a solution that was really easy, that was, you could learn it in one slide, in one session, and have your CUDA code, write it, and already outperform your CPU code right off the bat was really critical. So logically, that made making CUDA just C on the GPU a totally natural and logical thing to do. So our whole system was originally designed around the point of you can just take your C program, identify your data parallel parts, with a few keywords here and there, compile them down to the GPU, and seamlessly, offload your computation to the GPU. And today, we're really promoting this heterogeneous computing environment, where the CPU and the GPU are, they're peers. In the same way, back in the old days, we had the x86 and the x87, this floating point coprocessor. You didn't program it through an API or a device or as a separate thing hanging off the side of your PC. It's really this heterogeneous environment where you just have floating point operations and the compiler knows what to do with them and offloads them and the programmer doesn't necessarily have to think about which processor things are going to run on. CUDA, we made it such that it's really easy and simple for people to specify which part of their code are the data parallel parts, and our compiling toolchain simply allows them to run those parts in the GPU without having to learn new languages or APIs.